Hi, so in this video lesson, we want to look at the fundamental quantities and their units. So, what are fundamental quantities? Fundamental quantities are basic units or basic quantities or units from which all other quantities and units are derived from. So that's what we call the fundamental units. Are the very basic ones that very basic quantities that other quantities and units are derived from. So one of the fundamental quantities I want to look at is actually length. Length. And length is actually measured. So that's the quantity length. The unit for length is actually meters. And the abbreviation for the unit is m, small letter m. So meters, small letter m. Then the next point we want to look at is the mass. So the mass is measured in, that's the unit kilogram. Kilogram. And the abbreviation is kg. Then we have the time. Time is measured in the SI unit for time is actually seconds. And the abbreviation is just a small letter s. Then we have the temperature. Temperature, I know you might want to be tempted to say that the unit for temperature is degrees Celsius, but no, that's not the standard unit for temperature. It's actually Kelvin. So Kelvin is with capital letter K. Then we have electric current. Electric current is another quantity, electric current. And the unit for electric current is actually ampere. And that's a capital letter A. Then we have amount of substance. Amount of substance. And that unit of amount of substance is actually mole. And the abbreviation is MOL dot. Then we have the last one we'll talk about is luminous intensity. So pardon my handwriting, pardon me, I don't really have a good handwriting. So it's measured in candela, measured in candela and just CD. Okay, so these are the fundamental quantities that we have. But basically, you can just, for the meantime, at least be familiar with these ones: length, then these ones. Be familiar with these ones: length, mass, time, temperature, electrical current. At least those 5. Be familiar with them. They want to talk about the derived unit. Okay, now the derived unit. The first one to talk about is area. We're looking at derived units and quantities. Derived quantities and units. So the first one to look at is area. So what's area? Area can be length times length or length times breadth, as the case may be. Let's do length times breadth. And of course, that has to be what? Length is measured in meters. Breadth is measured in meters. So m times m gives us what? What's the unit? M squared. That's meter square. So this is the derived quantity, area. And this is formed by two lengths, L by L or L by breadth. Both of them are length. So they measure in meters, and that gives us m squared, the unit. Then let's see another quantity. Let's see volume. So volume is actually given by length times breadth times height. Okay, so that's m multiplied by m Height is also measured in meters, and that gives us m to the power of 3 meters cube. This is the quantity and this is the unit. Okay, good. Then we have density. That's another derived quantity, density. Density is actually mass over volume. That's the formula for density, mass over volume. And mass is measured in what? Kg. Volume is in what? We just said that, meters cube. So you can see that we are deriving it from what we have looked at before. Meters, volume is meters cube. So the unit for density is actually kg per meters cube. That's the unit. Then speed or velocity, as the case may be. Speed is actually, or velocity is actually distance over time. Let's say distance or displacement, as the case may be. Let's say distance, let's be specific. Let's say distance divided by time. So distance is measured in meters, as length, how far you've gone, meters over second. So the unit for speed or velocity is actually meters per second. So you can see the way I'm deriving their units and the quantities. Then let's look at acceleration. Acceleration. Formula for acceleration is actually velocity. That's velocity over time. Velocity over time. So what's the unit for velocity? Well, I want to derive the unit for acceleration. So that's velocity is meters per second. That's meters per second over second. And that gives us meters per second squared. So that's the unit for acceleration, meters per second squared. Then we have force. Force is actually mass multiplied by acceleration. And acceleration, let me just put that. And mass is measured in kg. Acceleration is measured in meters per second squared. So you have meters per second squared. So the unit is kg meter per second squared. But standardly, we say that is actually unit newtons, because Newton actually discovered the concept of force, Newton. So and that will be capital N. So this is the SI unit for acceleration is Newton. Okay, good. Then let's look at another quantity. Let's say weight. So which is actually a type of force that is downward, and that's due to the Earth's gravity. And that's same thing, mass times acceleration due to gravity. And so weight is same thing, this is a force, still newtons. So then we have momentum. Momentum is actually given as mass multiplied by velocity. So what's the unit of mass? Kg. Unit for velocity, we have looked at that before, is actually meters per second. Velocity, meters per second. So meters per second. So the unit is actually kg meters per second. So that's it. Then look at pressure. Pressure is actually force over area. So what's the unit for force? Unit of force is Newton, and the area is meter squared. So the unit is actually Newton meter, or let me just say Newton per meter squared. Unit Newtons per meter squared. but standardly pressure is actually measured in Pascal, and that's just capital P small a dot. So that's the abbreviation for Pascal. Then we have energy or work, as the case may be, they mean the same. They are the same unit. So work or energy is actually force multiplied by distance moved. So force is measured in newtons and distance is measured in meters. That's Newton meters. But standardly, you say that is actually joules. It's measured in joules. Let me spell that properly. Joules. And it's just represented with a capital J. Okay, good. Alright, so let's deal with just one more. Power. Alright, power. Power is actually work done over time. And work done, as you have seen, is joules. Joules over time is second. So power is actually joules per second. But then standardly, power is actually measured in watts. And so we just use capital W for that. So these are the fundamental quantities and their units, as well as the derived quantities and their units. So we could actually just derive quantities from the fundamental quantities that we have looked before. So it's just a combination of whether derived or fundamental, as the case may be.